I would do Leetcode 290 word pattern. So we're given these two strings. One is called pattern. It has these characters, for example, A, B, B, A. And then we got a given another string with words separated by a space. So basically, we ask if this word, array of words, doesn't match the pattern given by pattern. For example, ABBA. That means there's a word that we refer to as A, and if the in this case could be dog, right? So whenever I say A, it has to be a dog, and then corresponding to that. And then when I say B, it has to be a cat. And then the next one is B, so there must be a cat following that other cat, so that matches. And then the other one is A, it must be a dog. So right, this array of words has to match the pattern in order as they appear. Now, what's the other case where it doesn't match? For example, A, B, 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 A. In this case, dog is A, cat is B. But then we see a break in the pattern, right? Because you have A as dog, cat B, and then we have fish. We don't have fish in the pattern. That's not correct. So it's false. Return false. All right. And then this last one is basically all A's, which should be dog, 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 but it's not. You just put dog, cat, cat, dog, which doesn't match the pattern. Now, to approach this problem, I'm going to use a combination of a map and a set. And the reason I have to use the set is because I don't know if the pattern have been using before with the same of word matching to another character. You'll see. Basically, we're going to go here. Let me. So we're going to look at this array of words. We're going to split that into an array of other strings. So you gotta have dog. You're going to split with the space as a delimiter, right? Cat, and so on. Now, you could write a helper function to go over and do the split yourself, but I'm going to use the already built-in function for split, okay, to save some time. But that operation itself should be take O of n, okay, just to do that. I just don't want to do it manually because it's going to be too long. Anyway, once we got that, we're going to basically match the pattern given they are the same length, right? If they're not at the same length, we already know it's not going to match the pattern, so we can return false early. Otherwise, same length, so we're going to match. Okay, I'm going to put a map, and I'm going to keep track of the pattern for basically, if I see an A the first time, I'm going to associate that with the first word I saw, which was dog. So whenever I see A, I should make sure there's a dog. Okay? If it doesn't, it's not a match. You're going to break the pattern. But then I got to be careful. Okay, what if somehow you associated another letter with dog? So that's the problem that I'm going to face. In that case, I don't have A, but then I'm going to store A with the dog, which is wrong. In that case, that's why I need an extra space, a set, to keep track of whether I've already seen the word dog and processed it. If that is the case, I'm an A and I see the dog has already been seen, but it doesn't match my A here. I don't have an A associated with dog. Does that mean okay, it's false or it didn't match a pattern? So something like that. Anyway, let's jump to the code and do it. So maybe by doing it's more clear. Okay, so if we take string s as a string with the word separated by space, we're going to split that. So take s dot split. That's the method in Java. Around the space, that's going to generate an array of strings. So string brackets array. Let's call it words. Descriptive. Like I said, this is an ON operation, and you could have implemented split yourself. It's just going to take a long time. So I don't want to do it myself. Okay, if I do that and I see there's the number of words doesn't match the length of the pattern, that's already no right away. So if the pattern dot length, parentheses because the string in Java, doesn't match, okay, the words dot length. Now length is it is an array, so you have to use length without parentheses. Okay, return false right away, not matching the pattern. And then if not, got the same length, after that, they have to have the same length. Okay, in which case we're going to go for a loop from I equals 0. As long as it's either pattern or words, it doesn't matter which one you use. Let me use pattern. Dot length, I plus plus. And then, okay, let's first take what's the pattern for this iteration. If I is 0, we're going to take the first one, right? Which would be that A. So if I take that pattern, that char at the I, store that in a variable, let's call it pattern char. And then I'm going to go through the word. So I'm going to words at I, brackets I, and put that string, let's call it word. So we got these two. We got to compare, right? First, we're going to look at the map. Now I need a map outside. Let's create a hash map of, in this case, it's going to be a character mapping to a word. That's the way I do it. There might be different ways of doing this, but I'm going to do it this way. Call it hash map, or you could call it, pattern to word or whatever. That makes make more sense, pattern to word, because the pattern is the key, word is the value. New hash map of character mapping to string. Okay, and then we're going to go here. Okay, let's look at a pattern to word. Does it contains the key for the pattern char? If that is the case, I'm going to compare. Okay, I keep track of the A already. Let's see if that A word matches what I have. Okay, so pattern to word get pattern char to access the word that's associated with this character. If that is not equal, okay, so I'm going to use dot equals in Java to the word. If that's not the case, I put a bang here, exclamation before it. That means I didn't match the pattern. Otherwise, I don't care. Okay. So basically, we're going to go the loop, and the loop has to find a flaw in the pattern and it return false right away. Otherwise, if you go through the loop and you don't find any flaw or error or problem, a mismatch, that means at the end of everything, having gone through all of that, it's going to be true. It matches the pattern. Okay, so that's the approach here. That's why I put the false there. And then here is the checking if we have any mismatch. Now, it could be the case, okay, it doesn't contain a key. So it's the first time that I see this pattern character. So in that case, else, I have the choice. Okay, I'm going to store that first with the word that I've seen. But I'm going to get it to the problem. What if I already stored that word in a different letter? So that's why I need the set, right? To check if the word set, let's call it word set. If the word set contains the word already, that means I already accounted for it in a different character, which would not match the pattern. So that's also a way to invalidate it. Okay, so let me put outside and define that word set. So I'm going to call it hash set instead of map. And this is going to be string. And I call it word set. Because basically, if I've seen the word before, I put in the set so I know. Okay, new hash set of string. And then that's another way of invalidating. Now, if that's not the case, else case, right? The else, you don't even need to write else here because you're already returning. So it's implicit else. Okay, in that case, I got to mark as seen. So this word set, I'm going to add the word because I've seen it. And I also can do the marking, associate the character with the word in the hash map pattern to word. So pattern to word, you're going to put the parent character, for example, A, and associate that with the string, right? The value is going to be, for example, dog, right? That's the word. And you notice that's pretty much it. Like I keep building this, and every time I'm just looking for mismatch, given these two problems. Now, let's try to walk through it. Maybe it gets more clear if you do it yourself, right? So I'll just quickly go through it. So first we take the S, split around the space. So we create the words, right? Dog, cat, cat. Pardon my trying to write it fast. Basically an array of strings there. So 0 is index 2 all the way to 3. So that's words. And then we're going to check, okay, given this pattern has 4 characters, does it match the number of words? It does. In that case, it skips this if here. But if it happened they have like more words than the pattern can take or less, you would return false right away. And then we make the hash map pattern to word. Let me call it PTW. I'll put a curly brace. And then you create the word set. Let's call it word set WS. And then we're going to go through the pattern or the words. Doesn't matter. I here. 0. Okay, got the A, right? Pattern care. Pattern care is A. Right here is going to be A. And then we got the words going to be dog, right? Where is dog? And we're going to check. Okay, let's look at the pattern to word hash map. Have I seen the A? No, I have not seen it. Okay, they go to the else case there. In that case, okay, have I seen the word? No, I haven't seen it. So I skip the if. So basically I'm going to put, okay, let's add the A to the map and associate that with the word dog. And then let's go to the word set and add the word dog because we have seen that. Okay, we got the map of A mapping to dog and got the set of the dog. Okay, next time it's going to I plus plus to the B, right? The second one. Okay, B. Have I seen it in the map? No. Okay, have I seen it in the set, the word cat? No. So I skip both of the F's here. And I just do the same thing. B associated with a cat. And then I add cat to my dictionary of set here. Great. Next time is going to be a B again, right? Now, I've seen B before, so I'm going to look at the word associated with B here. Let me put a different thing. Okay, B associated with cat. Okay, the word that I have that I'm right now at the index I, which is that's actually this one, right? Because I'm 0, 1, 2. Yeah. Is it the same or is it different? Right? If it's the same, I'm matching the pattern. I don't care. Now, if it's different, I'm going to return false right away. Now, I can see clearly here is the same, so I skip that if. And because of that, I'm just go to the next iteration. Right? We are here at this point in time. We finish it. There's nothing else to do. Just increment the I. So you would go to the next one, which finally A, and you do the same thing. Okay, have I seen the A? Yes. It's associated with dog. Is this word, dog word the same as the one I'm seeing in the I for the word? Yes. So it's matching pattern. I don't care. And finish it. Right? Now, if you had a different word, maybe you had something else, fish, right? Fish was here. If fish was there, you would look, okay, I got A associated with dog, but dog is different from fish. So this if would execute and return false right away. You don't match, right? Now, what's this other case that could happen if I don't know, somehow you had let's say, let's backtrack here. You had, right, this is a C or whatever. Maybe you had this word dog, and somehow the dog was associated with C. I don't know, for some reason. Then you're gonna look, okay, A, I haven't seen that before. Therefore, you would think maybe I can just add A is equal to dog. But the problem is, hey, you have already used dog for C. That's why we need to check the word set. Have I seen the dog? Yes, you have. Therefore, you cannot associate A with dog. So there's a mismatch right away, and you return false. So that's the edge case there. That's why I use the word set. Okay. And that's the explanation. I hope I was clear. Now, time complexity for this is the split's going to be O of n, given n is the number of characters in S. And then you're going to do a loop, which is going to be assumed they have the same length. So it's going to be O of n at least, plus that O of n, 2n, which simplify to O of n. Now, you could look here, okay, maybe any one of these could equals be something to cause concern to make it n squared. What do you think? According to what research I've done, this could be evaluated to all of n. But somebody might argue, okay, what about this equal? What's the time complexity? Are you nesting if you're comparing two things? Is it going to be constant time? You tell me. So I want to hear your thoughts. Anyway, so overall, I would say O of n. And space, obviously, you got n for this and n for the other one. So it simplifies to O of n, even though I have twice the sign. Okay, and so O of n for both time and space.